Chapter 7, Lesson 2, Congruence. You will be able to write congruent statements for congruent figures. If two figures are congruent, their corresponding sides are congruent and their corresponding angles are congruent. The symbol right here is the symbol for congruent. So here we have two triangles, triangle ABC and triangle DEF. Now if you take a look, AB and DE have this little dash here. That single dash tells me that these two lengths are congruent. So I can say just that. Line segment AB is congruent to line segment DE. Similarly, BC and EF have two dashes. So I can say that BC is congruent to EF. And lastly, CA and FD have three dashes. So I can say that CA is congruent to FE. All of those sides are congruent. Also, their angles are congruent. So angle A is congruent to angle D. Angle B is a right angle as well as angle E, so those two are congruent. And angle C has two arcs there. Angle F has two arcs, so angle C is congruent to angle F. Because all of these corresponding parts are congruent, I can then say that the triangles are congruent. One thing that I would like to note here, if you take a look at this, A, B, C, and D, E, F. The order matters. Angle A is congruent to angle D, and those are written first. Angle B is congruent to E, and those are written second. And C and F are also congruent, and they are written third. So the order that you see these letters, that matters as well. Let's do some examples here. Write congruent statements comparing the corresponding parts and the congruent triangles shown. So look at the dashes. Let's start with our angles. Angle G has one arc here, and angle J has one arc. So I can say that angle G is congruent to angle J. Similarly, I has two arcs and L has two arcs, so angle I is congruent to angle L. And H has three arcs, K has three arcs, so angle H is congruent to angle K. Now let's take a look at our angles, or excuse me, our sides. GH has one dash, so does JK. So I can say that GH, line segment GH, is congruent to JK, line segment JK. GI has two line segments, or excuse me, two dashes, and so does JL. And IH has three dashes, and so does LK. So those line segments are congruent. The only other statement speaks about our triangles. Triangle, I like to go in order of the arcs here to make it a little bit simpler when I write it, because remember, the order in which you write the letters matters. So I'll go one arc, two arc, three arc. GIH. Triangle GIH is congruent to one arc, two arc, three arc, JLK. And those are the congruent statements. Letter B, write congruent statements comparing the corresponding parts and the congruent quadrilaterals shown. It looks like these quadrilaterals were reflected over a vertical line. So with that in mind, I know that these two sides would be the same. These two would be the same. These two sides. And these two sides. Similarly, I can say that N is congruent to B. M is congruent to A. And P is congruent to S. And O is congruent to K. This time I'll start with the quadrilaterals. I'll go M, N, P, O, so I can say quadrilateral N, M, P, O is congruent to quadrilateral B, A, S, K. Now I'll do the angles. Angle N is congruent to angle B. Just look at the arcs. Angle M is congruent to angle A. Angle P is congruent to angle S. And angle O is congruent to angle K. In the line segments, which you can also do for line segments, a neat little trick here, as long as your letters are appropriately in the right order, you can actually name them from here. So I can say NM is congruent to BA. And then I can say MP is congruent to AS. And then PO is congruent to SK. And the last, I would say that ON is congruent to KB. And there are your congruence statements. Okay. I'll start with the triangles. I'll go NMO is congruent to STV. Again, make sure you are following the arcs and going in the same order. I'll go angles. These angles correspond also. So angle N is congruent to angle S. Angle M is congruent to angle T. And angle O is congruent to angle V. The side lengths, NM is congruent to ST. MO is congruent to TV, and ON is congruent to VS. Letter D. I'll start with the triangles. BCA is congruent to GJF. Angle B is congruent to angle G. Angle C is congruent to angle J. Angle A is congruent to angle F. And now the sides. Line segment BC is congruent to line segment GJ. Line segment CA is congruent to line segment JF. And line segment AB is congruent to line segment FG. Triangle ABC is congruent to triangle XYZ. Write congruent statements comparing the corresponding parts, then determine which transformation maps triangle ABC to triangle XYZ. Look at the notation. That is referring to the order of these here. It wants us to write the congruency statements. So here's the first one. I don't have to write it. But then I will say angle A is congruent to angle X. Angle B is congruent to angle Y. And angle C is congruent to angle Z. And the line segments, AB is congruent to XY. BC is congruent to YZ. CA is congruent to ZX. And also, we'll write this as a congruency statement. Triangle ABC is congruent to triangle XYZ. So if I have that angle B is congruent to angle Y, what looks like happened is that figure reflected over the x-axis and then it moved down. So the transformations then would be a reflection over the, and actually y-axis, I believe I said x-axis, I meant y-axis, reflection over the y-axis, then a translation. How far down did it go? Well, if angle B was reflected over the y-axis, it would be right here. So how did it get from this point to y? It translated down 2 units. So a translation down 2 units. Parallelogram WXYZ is congruent to parallelogram KLMN. Write congruent statements comparing the corresponding parts, then determine which transformations map parallelogram WXYZ to KLMN. So let's start with our shape congruent statement. So parallelogram W, X, Y, and Z is congruent to parallelogram KLMN. Okay, we'll do our angles. Angle W is congruent to angle K. Angle X is congruent to angle L. Angle Y is congruent to angle M. And angle Z is congruent to angle N. Our line segments, WX is congruent to KL. XY is congruent to LM. YZ is congruent to MN. And ZW is congruent to NK. There are congruency statements. Now we need to figure out what transformation happened. Well, I know y is congruent with m, and I'm just picking a random set of angles. Doesn't matter. You can pick whichever one you want. Well, how did I get from y all the way to m? Well, it looks like I reflected over the x-axis. And when I reflect over the x-axis, my point ends up right here. And I still need to get to m. 1, 2, 3, 4, 5. So it looks like we had a reflection over the x-axis and translation left 5 units. You can use properties of congruent figures to find the missing measures of angles and sides in a figure. Use the following figure to answer the questions below. Miley is using a brace to support a tabletop. In the figure, triangle BCE is congruent to triangle DFG. If the measure of angle CEB is 50 degrees, what is the measure of FGD? Well, it looks like these two triangles were reflected over a vertical line. So that tells me that angle E is congruent to angle G. So if angle CEB is 50 degrees, then the measure of angle FGD is also 50 degrees. And let's put a little explanation here. Because they are corresponding parts, and therefore congruent. Okay, now we have the length of CE right here is 2 feet. What is the length of FG? Well, CE would correspond with GF, so it's actually going to be 2 feet, and it's going to have the same reason.